So this is question 5 from 2017 higher level paper 2. We have a rectangle ABCD. We have to prove that triangle AFE and triangle DE are similar, which means that angle at EF and A over here are the same as angle D and A are similar, angle E are similar, and angles F and this angle here are similar. So the way I'm going to write down is that I'm going to call this angle here A1, and I'm going to call this angle here A2 for the sake of simplicity. So then from the first triangle, angle at A plus angle at A1 plus angle at F plus 90 degrees are the same as angle at A2 plus angle at D plus 90 degrees. So I'm going to cancel 90s because there is no need for that. Also, I'm going to note that angle A1 plus A2 are equal to 90. So then A1 equals to 90 minus A2. So I'm going to substitute that, and I'll get that 90 minus A2 plus F equals to A2 plus D. A2 plus D. Now, so this might be a little bit difficult to see and recognize, but the key discovery here is that the sum of those two angles is equal to 90 degrees. And that comes from the fact that A2 plus D plus 90 is 180, so those two angles have to sum up to 90 degrees. So from here, I'm going to get, I can cancel 90 and those two angles, and I'm going to get that A2 equals to F. So angle A2 has to be the same as angle F, as an implication of that, angle A1 has to be the same as angle at D, and both of those triangles share 90 degrees, which proves that they are equiangular. Then the next part of this question is to find segment AD. So then the next part of this question is to find the length of segment AD, and what I'm recognizing over here, that AD angle at D is the same as angle at A1, which means that I can actually find what that angle at A1 is. So angle A1 is equal to tan minus 1 of 5 over 12, and that gives me 22.61 degrees. And then finally AD to 12 over the length of AD is the sine of angle A1. Those angles are the same, angle at A1 and angle at D are the same. So what I can say that AD is equal to 12 divided by sine of 22.61, so that will give me 31.2 centimeters. So then the next step is we have to show that triangles AFE and AGB are similar. We have to show that length of AB is equal to 36 centimeters. So what I'm recognizing here is that angle at A is shared for both of those triangles. So GAB is the same as EAF, which means that cos, we're looking for length of AB. So cos of angle A is the length of AB over 12 plus 27. So AB equals to equals to 39 multiplied by cos of 22.61 degrees, and that equals to 36. And then finally we have to find the area of quadrilateral GCDE. So first things, I'm going to find area ABCD, which is equal to 36 times 31.2. That gives me 1123.2 units. Then I'm going to find length of segment BG, which is equal to root 39 squared minus 36 squared, and that equals to 15. Then length of segment ED equals to root 31.2 squared minus 12 squared, and I'm going to use that to find area of triangle AGB, which is equal to 1/2 times 36 times 15 equals to 270, and also area of a triangle ADE, which is equal to 1/2 times 28.8 rather times 12, which is equal to 172.8. Reason for all those calculations is as follows. I'm going to find, I found the area of the big rectangle, and to find the area of the shaded quadrilateral, I'm going to subtract area of triangle ADE rather, so this triangle here. I'm going to get rid of that area, and then finally I'm going to get rid of the area of this triangle here as well. By subtraction, I'm going to find the area of the required quadrilateral, so that area will be equal to 1123.2 minus 172.8 and minus 270, and that gives me total area of 680.4 units.